you've got some central atom that you're talking about. And then around here, you have some electrons here, and some electrons here, and no other electrons. You recognize that as linear, right? In this case, the electrons are going to be the electrons in a bond. Going to an atom. If one of those is a pair of electrons, or both of them is a pair of electrons, I won't be asking you about it. So that's all there is to linear. It's going to be a central atom, the two atoms out here, no pairs of electrons, nothing else around it. Only electron regions, is that what it calls it? Some would say electron domain. Number of electron regions, okay. That's really obvious, but it makes you wonder what I'm trying to contrast it from, unless I do the next one. If you have three things around it, I'll go ahead and draw it this way. And there's nothing up here, nothing here, nothing here. That's the totality of the three things that are around it. What's the shape you get there? Planar, trigonal planar, triagonal planar. Question?
Those are the same image you showed on this one too.
I didn't use it. I guess you have to go on.
This is molecular shape. So
Oh,
this
is it?
also has the same images on there.
That one's okay, except it's supposed to be charged.
Even though
Actually,
it had extra electrons on the hydrogen.
Exactly. Well, it had an extra. Oh no, it shouldn't have all the electrons.
Yeah, that one still has all the electrons on the hydrogen.
And that was the shape. That might be what's screwing y'all up. I made a ridiculous example for this first one that was wrong. That one's not okay. Did the other one have all the electrons around it too?
Yeah. What does that mean? I mean, that's what you
Well, those are wrong. That's why I'm believing.
The hydrogen should have one extra one.
So we say it's not as this one with more pairs? That makes sense.
How many questions are on the test?
Oh, yeah.
One question is.
All right, so you guys were able to say trigonal planar.
That's if it has no lone pairs, right?
Exactly. The only three things around here are three atoms. And the electron domains are really this, this, and this. Those are the three electron domains.
When there's lone pairs, it's bent, right?
Yes. Let's stick with three things around it, three regions. Now let's say this one is the pair this time. Now what would you call it? Well, you just call it bent. You just call it bent. And truthfully, it is more like this. The way you would expect it to be if it's 120 degrees. So that's bent at 120 degrees. This bond angle is 120 degrees. You with me? If I took another atom off, that's something I wouldn't ask you because then there's only two atoms there. It really doesn't make sense to ask you about it.
Will you give us?
Yeah, that one.
This one's bent 120 degrees.
Because it has three.
Will you give us conversion factors for like pressure and stuff, or do we need that?
Yeah, I'll give you those.
Okay. So we just need to know.
So that's all the examples when there's three things around it. All of them are atoms. That's trigonal planar. Or two of them are atoms and one of them is a pair, and then you have bent at 120 degrees.
I thought that has lone pairs. I thought that was a whole other region. So I thought that'd be like.
I'm just drawing a line to that. So that's a region, and that's a region.
Can you give me an example? Like, can you write an example where it's like after that?
Okay, that's trigonal planar. But what if I had?
Okay, yeah, so it's 1, 2, 3.
Yeah, This counts as one electron domain, so now it's three things around it. You might see it drawn like this, though. And you still should recognize there's three things around it. 1, 2, 3. You see what I mean? One electron domain, another electron domain, and a third electron. You guys with me?
Wait, there's one electron domain, but in between the nitrogen and oxygen, there's one under nitrogen?
These two count as an electron domain. This counts as an electron domain, and that counts as one.
A lot of them dots are one electron.
But it comes down to this. If there's two atoms around it and no electron pairs, you have linear 180 degrees. If I tried to replace one of these with a pair of electrons, I'm not going to ask you about that. So we go from here, linear, to now let's go to three things around it. Three things around it. They're going to organize to where they're 120 degrees apart. That's trigonal planar. Because they're going to organize and they're going to repel each other and turn into that perfect symmetrical 120 degrees. You with me?
Yes.
All right. If one of these is a pair of electrons, we still have that 120 degrees shape, but we ignore this pair of electrons and then just name the shape we have left. That's when we're going to say bent at 120 degrees, because we're ignoring this part. You understand? Let me draw it to where it looks. Pair of electrons. So that's what makes the shape. 120 degrees, 120 degrees, 120 degrees. But at this point, once there's a pair of electrons there, you ignore the pair of electrons in your eye, and you think, what's that shape without that? Bent at 120 degrees. It's this part we're naming the shape of. We're ignoring that pair.
So you know to ignore the other part whenever it's an electron pair?
Yes.
Okay.
And, okay, electron pair. If this was an electron pair, I won't ask you about it.
You won't?
No.
Okay.
So this is what's in that chart too. Linear, 180 degrees. If there's any pair of electrons, I won't ask you about it. Now let's go to three things around it. If all three things around it are atoms, no pairs of electrons, trigonal planar. If one of them is a pair of electrons, bent 120 degrees. Okay, that's two things around and three things around. Let's go to four things around. Yep, tetrahedral. If all four things are atoms, it's just tetrahedral. And that's the one that has the weird angle. Remember the angle? 109.5. Now let's turn one of them into a pair of electrons. What's that shape? If you ignore this? Yes. Trigonal pyramidal. Because you've got these three things that make the base. That's trigonal pyramidal.
Okay, so
Here's an example. Four things around it. 1, 2, 3, 4. One of them's a pair of electrons. This one's trigonal pyramidal. I can't draw it on the board because it's tetrahedral. I should get the model kits out, but it's the one that looks like this. It's like that, sort of. So I can't draw it on the board. But if you ignore, say, this part, you've got the atom in the middle, and then you've got the base of a pyramid here.
and that's
A pair of electrons will be at the top. That's the trigonal pyramidal.
But for planar and the pyramid, for planar, there's two atoms, electron pair, you know, electron, so that's true.
For bent, the one that had three things in total around it, if all three of them are atoms, it's trigonal planar. If it's got two atoms and one pair of electrons, then it's bent at 120 degrees.
And then, so what's the difference between pyramid and on that one?
There's no planar when there's four things around it. It doesn't fit in the plane anymore.
So that one's trigonal pyramid.
When it's three things, it's literally flat like this. If you could zoom down with a microscope, you'd see that it's flat when there's three things. But once you get four things repelling each other, now you've got to deal with three dimensions, and you get this tetrahedral shape. So once you get four things around, you're not planar anymore. It doesn't fit in a plane, so you just say tetrahedral for that. And then if one of these is a pair of electrons, you just, in your mind's eye, you ignore that pair of electrons, and what you'd see is the trigonal pyramid. You could, and this is what they do in there. If you've got two electron, what do they say, regions? There's only one example. When you have three electron regions, then there's two examples. When there's three total things around it, there's only two examples to worry about. One of them is trigonal planar, one of them is bent at 120 degrees. When we go to four things, four electron regions, we've got the one where they're all atoms, but I can't draw the plane of the board now. What I'm trying to depict there is that. Do it again. So now it doesn't fit in a plane that looks kind of like that. Okay. So, but that's what this is. Four things around it. It makes this tetrahedral shape. And there's four atoms around it. The other examples are central atom, now with a pair of electrons. If this were a pair of electrons, then it would be the trigonal pyramid. That would be the trigonal pyramid.
Can you practice doing these like from like two the real compound, or like when you have to draw the instructions of check to find valence electrons?
You won't have to draw them. They'll be just like in the quizzes. You just have to recognize them from A, B, C, D, or E.
In the quizzes they have, my question is kind of the same. In the quizzes it asks like, it'll be like, what is the molecular shape of Cl? Oh wait, yeah. It'll like, you have to draw it yourself. Like, be in this molecule, BF4, and you like go.
Which one are you on? Which quiz?
I'm on molecular shape better. Go to question 20, or 23.
Just because
Because you have to write it out for yourself and then figure it out. I just didn't know if we would have questions like that on the test.
Oh.
Like the big.
Yeah. So there you have four things around it.
I'm at number 23. Sorry. Oh wait. Oh, I guess our 23 is different.
Is it different in here?
Yeah. It like, it doesn't give like a
If it doesn't have a picture, then it's a mistake.
oh, okay.
Yours just, maybe if you refresh it.
Yeah,
Do you
okay.
have that structure anywhere? Have you seen that one?
Yeah, I saw that one. I just wanted to make sure we didn't have to
Yeah, I'm gonna give you the structure.
Okay.
Like for that one, it'd be 1, 2, 3, 4, 5, 6.
These all count as one domain. They're all going to one atom.
And then all of the lone pairs count as one, so it'd be
Well,
6.
this one says, what is the molecular shape of C? So we're talking about this right here.
Okay.
The fact that this is N doesn't matter, and the fact that this is Cl doesn't matter. You're looking at C, it tells you to look at C. So what's the molecular shape around C? You've got one domain here and one domain here, so that's two things around it.
It's just
And both of those things are atoms. So it's what?
linear.
Linear 180 degrees.
Then do you think you could do that one too? Like that one right there?
This
The one
one?
that has the brackets around it?
This one?
This
The brackets are just there because that's what you're supposed to do when it's charged, and you put the charge up here. That's not going to mean anything. Just look what's inside the brackets and deal with that. So how many things are around that bead? It says look at the bead. So what's the shape? None of those four things are pairs of electrons, so that's it. It's tetrahedral.
The lone pairs are just two to meet up.
Well, these lone pairs are not on the central atom. And you're looking at, this tells you to look at B.
Okay.
So you're specifically looking at B, and it doesn't have any lone pairs. You see that?
This one.
Saying, this tells you to look at silicon.
Oh.
I guess some of these don't have. E, let's see, X, E,
Oh.
What about this one?
Oh, that one's.
How many things around it? The carbon? Three. And none of them are pairs. So you're gonna find.
If it was asking for the whole structure itself, on the,
So that one would be triangle pyramid, right?
Yes. Four things around it. One of the things around it is a pair of electrons. Follow
if it was
that?
asking for the molecular shape of the whole molecule itself,
It turns out that this whole molecule is that shape just because this happens to be a molecule that has a central atom. But that's not the best way to think of it. That's why I'm going back in here and adding which atom I'm talking about,
okay.
because that's a better question.
Okay, are there gonna be like questions on the test that ask the molecular shape of the molecule in as a whole?
No.
Is it just that?
Yeah. That's why I'm going back and adding them.
So, Dr. Everett, do we get the pressure conversions on the test?
Yeah.
Okay. And then do you think whenever you have a chance, you get the stoichiometry problem?
Yeah. Which one is that?
It's the last one, it's like,
Stoichiometry of gases.
is it?
Let's look at these. Let's look at these molecular shapes. Now that I fixed those. How many things are around it? The carbon. So what's the shape? Phosphorus. How many things are around phosphorus? What's the shape when it's 5?
Triangle pyramid?
Yep. Were you looking at the cheat sheet?
Yeah.
Only a few of these doesn't take a lot of thinking. This one's misleading, but how many things around it?
4.
Yep. 2 of them are pairs. They call it. It's this. Picture that tetrahedral shape and then ignore 2 of the things coming out. You just got, well, it is initially kind of tetrahedral. It is kind of initially tetrahedral. But if I take two of these things coming out from the center, bent. But this time it's not 120 degrees. Now it's the tetrahedral 109.
And we're gonna need to know the degrees.
Henry, please use the sheet on test.
You can do this. Let's go through the rest of these.
Like, I have to memorize this.
I need to
I
be
need like a
rushing.
goniometer or something too, figure out these degrees.
I understand it.
Like,
I
in the
might
sheet,
be
it's telling
tempted to
you
give you
memorize
some of these weirder ones down here, like when it's T-shaped and when it's sawhorse and all that. It seems to me these you should.
like just a linear one, I can do that.
Can you?
Can you give us past 4?
Huh?
Can you give us the ones past 4? Like 5 and 6?
What if I gave you two of them?
I would have been very helpful.
If you're asking them those hours,
If I see one of those, this is what,
Okay, what if I said I'm going to put any of these on there?
any of 5 and 6.
I'll put 4, 5, and 6,
there we go.
but 4, 5, I'll put 4, 5, and 6 ones on there, but it'll either be all of them are atoms or one of them is a pair of electrons and the other is not.
Alright, let's do some practice on that.
Let's go through it.
Those are the fun ones.
The carbon.
Carbon,
How many things are around it?
2.
How many of them are pairs of electrons? How many of them are pairs of electrons?
2, 3, 4, 5, 6. I see 6.
No, these, well, lone pairs. These two guys.
Oh,
Yeah.
No, so what's the shape? Linear.
no. What?
Yes.
There's no
We're only looking at this carbon.
Oh.
So the outside atoms don't matter?
Yeah, so it doesn't matter if the O has 4
Well-
things on it?
I know I said it in class, and I should probably say it over and over. The fact that we use the word molecular is a misnomer, and I wish we didn't. Well, every time you get this in a book or anywhere else, they're asking you for the shape of one of the atoms in the molecule. So I specify which atom that is. It's carbon. So just look at the carbon and do this analysis. It's got no pairs of electrons, and it's got 2 things around it. So it's linear.
Wait, so you're only ever looking at the middle atom?
Well, look at the atom that I named here, because there's not always a central atom. I'm naming the atoms around it. So I'm telling you, look at S here. Look at the S. How many things are on it? Yes. You see that? There's 3 things.
So one is the lone pair.
Right.
So the
Bent. 120.
How do you know which one's me?
Because there's 3 things around it.
Okay, if it's
Only
4,
3, it's 120. Then 120. 4 is
I'll go over other things while y'all
3 things around it.
find molecular shape. Right.
we're still here.
Yeah. No, I'm sorry. I need
You good?
No.
Okay, yeah, so 3 could go.
Yeah.
Not
So,
good.
wait, hold on. So if it's 3, it's 120. If it's 4, it's 109.
Yes.
Okay. Okay, let's.
How many things are around the nitrogen?
4.
The one.
And it's
So
bent.
it's 109.
Wait, no, it's tetrahedral pyramidal. What?
Tetrahedral.
Or it's triangle pyramidal.
Trigonal. You've got a list of all the names here, and you'll have that on the test.
Yeah, but then they're all going to be mixed up in my head unless I got the sheet right here.
But you don't see a tetrahedral pyramidal choice.
All right. What's going on?
Try.
Try this. Um, 3 things around. It's going to be 3 atoms, or 2 atoms and 1 pair.
Because it has one.
That's tetrahedral,
Yes. If there was that.
and that's trigonal pyramidal.
Wait, so when is this bent? When is it bent 109?
When they're
3 atoms, tetrahedral, I thought that was trigonometry.
Them, if there's gonna be bent at the tetrahedral angle, then you gotta have 4 things. And that's when you have 4 atoms, then it's tetrahedral. If you have 3 atoms in 1 pair, that's a trigonal pyramid. I did that one wrong, y'all.
Yeah, I thought three.
Yeah, this one's bent.
trigonal plane.
That one's bent at 100. That's when you have 3 things around it. It's this.
Yes.
3 things around it, but one of them is a pair. That's bent at 120 degrees. That's
When
this.
it's been
When?
109, when there's 4 and 2 of them are
Yes,
pairs.
that's what's going to go here. 2 atoms, 2 pairs, and then it's bent.
Got it.
So y'all can do those without a chart.
These, yeah, this is perfect.
Wait. When you wrote 3 atoms, you said it's tetrahedral. I thought that was trigonal plane.
Yes.
Yes.
Yes. At least you saw that I did it wrong.
I was like, wait.
Trigonal planar, bent 120, tetrahedral, trigonal pyramidal, bent 150. So this is right. That's what's in that chart. The chart does this. It does this one, then it goes down and there's 2, and it goes down and there's 3. It's exactly what's in that chart.
That's why the chart, you know this.
If you have 5 things around it, and all of them are atoms, trigonal bipyramidal.
Yeah, those we're gonna need. Yeah.
What if you have 4 atoms? And then I said, okay, I won't do any of those.
You are going to teach you?
I'll just stop there for the 5s.
Yes.
Okay, if you have 6, all of them are atoms. What is it? Octahedral. What if you have 5 atoms?
Square pyramids. Square.
Is that one square pyramid?
Yes.
Yeah. And then square planar. So I think we do the first two off.
Those you could memorize. If you could analyze it enough to go, there's 3 things around it, and 2 of them are atoms, and 1 of them is a pair. You could memorize this much. Could memorize the rest.
Let's do this one first.
Yeah.
Do we need to know like those 20 and 20?
So this one,
That one's
Triangle here.
trigonal pyramid.
Is the pyramidal the same thing?
How many things around it?
Six. Oh, sorry, six.
So what is it?
It's with octahedral.
Does it matter that there's a bunch of those lone pairs on it?
No, because we're only talking about the yes.
Okay.
How many things around this has?
Oh,
5 things around it.
seesaw.
Yeah, that one's seesaw.
Because of the
5
lone
things
pair
around
on
it,
the
one
S.
of them is a pair, so that's seesaw.
So 4 atoms, 1 lone pair?
Yep. This one. 5 total things around it, but 4 of them are atoms and 1 of them is a pair.
It's making a lot more sense.
How many things around this?
Yeah, 6.
6 things around it.
Square.
So that one would go right here.
Square square plane.
That one would have been square planar
No,
instead
we're
of
fading out.
square pyramid.
Yeah.
We're not doing it.
So we're only doing up to 1 lone pair?
Yes.
Yeah, for 5 and 6.
1, 2, 3, 4, 5, 6.
See, but I only know this because I'm looking at the chart.
Yeah.
Yeah.
How many things around,
Trigonal
move things around. 5 atoms, no pairs, so that one's tetrahedral. How many things around the nitrogen? Yes.
So it's then
Yes.
120.
Yes.
Yes. Wrong. Wrong.
How many things around it? 4.
So it's then 109. No, it's trigonal pyramid.
Yeah.
Trigonal pyramid.
Trigonal pyramid.
There's four.
You just saw it.
No, we don't.
Does the -2 not have anything?
No. For the shape stuff, you can completely ignore that charge. It just needs to be there, so I'll put it there. That 120. That 120. Did I lose you?
No.
Somebody said wait. You got 2 lines and 1 pair, so that's 3 things around it.
Oh, trigonal plane.
One. There's no pairs around it. Trigonal pyramid.
We should put so many of these on there. The tetrahedral ones.
I would put that back on
Let's just
there.
do a test.
This one's missing a
Let's just
picture.
do a test right now.
Oh, no.
I'm just gonna delete that one. For some reason the picture didn't come along. It's tetrahedral. Well, I'm gonna be asking you this one.
T-shape.
This one would have been T-shaped.
Reading that one too. And that's it. 100.
Tetrahedral.
It was the one without the.
I clicked the wrong one. Y'all probably said it correctly. Trigonal bipyramid. And the other one is 21.
Well, I think we do gas. Yeah. The geometry of gas.
Geometry with gases.
Function is in your class.
You need the branch for long.
You never know. Very good.
Tells you pressure is 1.24 atmospheres. And temperature is 375 degrees. You know, yeah, it's kind of like this. I should have given you the R value here. Let me make sure I use the right R value. 08206. 08206. Assume this is there.
Are we gonna have the R value? Like on the test?
Yeah, I'm going to give it to you. And I'll give you this too. What volume of O2? So we're trying to find the moles of O2. So oxygen, there's 2 of them. They weigh 16.
Wait, 1 second. Let me-
This is what you do first. You find the moles of the O2. We're also going to need,
Don't we have to convert
Yeah.
micrograms of AL2O to
Yeah.
converts?
yeah. We're going to need AL 36. AL is what?
26.98.
There's 2 of them. And oxygen, there's 3 of them. So what is that? Who's got a calculator out?
101.
What is it? Your big numbers?
That's not right. What is 2 times
Oh,
26.98? Would you,
53.8.
what is it?
53.8.
8 what?
That's it. 0.
0, okay.
And then
3 times 16.
48.00.
So you add these up and what do you get?
You get
101.80.
101.8.
80.
0.
Grams per mole for this. So you start with and then you do the grams per mole. So grams need to be on bottom, so 101.
Did you get the 34.6?
That's given to you.
Oh. I got 101.96 for the final.
You got something besides this?
Yeah, I got 101.96.
It's 26.890. Certain.
I got 53.96.
Does it say 26.98 on the periodic table? And then 2 times that?
I got 53.96.
Say it again.
96.
So this would be 96. This would be 96. All right. Moles of Al2O3 goes on the bottom here. And then moles of O2 goes here. So now we're caught up to the O2. Oh, I didn't write the equation. We've got 4 ALS plus 3 O2 makes 2 AL2. So it's 2 to 3. For AL203, it's a 3 volt. So it's a 2 here and a 3 here. You see how I set that up?
Oh, okay, but you're not there?
Yeah, I just wrote it right here.
Oh, okay.
You see how I set that up? All of these will be set up the same way. So you calculate across here, you end up in
60.2 something.
right, 34.6 times 3 divided by 101.96 divided by 2. 0.509 moles of O2. You with me? If you have that, you don't have to calculate the oxygen. Now we're going to use PV equals nRT. We've got PTR. Volume is what we're looking for. So we've got PTR. Volume is what we're looking for. And we just found moles. That'll tell you the volume of O2 needed to be added in here to get 34.6 grams of AL2O3. Volume equals nRT over E, 0.509, 0.08206, 375 Kelvin. Over pressure was 1.24. That'll give us a volume. Is there a 12.6 on there?
Yeah.
And all of these will be done the same way. You okay with that?
All the rest are the same way.
Yep, exactly the same way. 17.5 grams of NA3N. That's these grams. You're going to have to find the grams per mole for that. And the mole ratios from the equation. We can do more of those, but it's exactly the same. Maybe more of those. Huh? This is the one I use on the board. But every one of these equals one atmosphere. So I'll give you that.
Dr. Emperor, what time is the test on Thursday and Friday? Do you know off the top of your head?
3:30 to 5:45.
Both days?
Both days.
Okay.
So all of these I'll give you on the test. Okay, so for these conversions, it's on 4 inches of mercury. Do all these say conversion atmosphere?
The last 3 yards.
13.4 is what's given in the problem. Inches of mercury. Now this pen's going to suck too. So what you're looking for is atmospheres to inches of mercury. Did I not write it down?
It's 29.
No, I didn't write it down. It's this that we need. So the 1 is here, and the 29.92 goes there. this is what was given in the problem. And it's atmospheres to inches of mercury. So 13.4 divided by 29. On 2. 1448.
Is it gonna be set up like that every time?
Yeah, well, look at this one.
Or the ones that
PSI to millimeters of mercury. We're going to need PSI down here. And we've got PSI to atmospheres. There's a few PSI to atmospheres. Then we're going to put atmospheres down here. And millimeters of mercury here. I don't want to cut that one out. That one. So I'll give you that, and I will also give you this. So you're just setting it up, so this is what's given in the problem. You put PSI on the bottom. You got PSI to atmosphere, so you write that in here. 1 atmosphere is 14.7 PSI. You with me? And now atmospheres to millimeters of mercury. 1 atmosphere is 760. But the answer's wrong in there, though. Maybe I'll delete that one. Yeah, I've got 2874.5. So that's 3 significant figures, that's 3, and that's 3, so I'm keeping those 3. So the answer in there is 2870. So I ended up using 2 of these, and maybe atmospheres cancel out. So that way I was able to get from PSI all the way to millimeters of mercury. Pascals to torr. So convert 1.25 pascals. So okay, we're going to go from pascals to atmospheres. Atmospheres to torr. These are going to be ones based on what I've given you here. 1 atmosphere is 760 torr. PA, this 101.325. And the torr is 760. 3 significant figures, 3, this is really 3. It says in that chart exactly 760. And then 6 significant figures, but we want to end up with 3, so 1.25 times 760 divided by 101, and I get 9.38. .25 times 760 325. I don't know. So I'll tell you what. I'll bother with that one. So just be able to do one of these this year. I just deleted that one because I had the wrong answer in it.
So whenever you set up a conversion, you always start with what you're given? You always start with what you're given?
Yeah, that's the way I always do it.
Okay.
You could do the algebra in a different order and still get the same answer. I always take what's given, and then I take my conversions and build it in and do it.
So the second one is the same as like the first one, right? Like that. And all you do is do like 3.4 or 1.
Yeah, this one goes straight to atmosphere, so you only need millimeters of mercury to atmospheres for that. But if you're going from something other than atmospheres to something else other than atmospheres, then you're going to use 2 of the atmospheres things to make them cancel, and you end up relating to the mass volume. What else was y'all want to know?
You can possibly do some PV and RT, the one with the, where it's like you're converting, it's question 3 on there. It's like volume and moles, what you have to work with. Yes, that one.
First question is something changing? So what's changing?
It's the PV and RT.
Yeah. R never changes. All right, so first, what isn't mentioned at all here? So pressure is constant, temperature is constant. Okay, 101 moles of gas, 1.01 moles of gas occupies 6 liters. If 1.22 moles of gas are added, we end up with 2.23 moles of gas. All of that. I added 1.22 to 1.01. And that's how I got N2. You with me? There you go. There you go. What's changing, you want on the left. What's not changing, you want to put on the right. So divide both sides by N. can now divide both sides by P. And then those two things that are changing, you go V1, N1, V2, N2. You've got 3 out of 4 of those variables and you solve for the fourth. We're trying to solve for N2. So if I multiply both sides by N2, I'll have V1, N1, N2, N1. So multiply both sides by N2. So then I'll have N2 times V1 over N1, and then just plug everything in. V1 was 33.6 times N2, which is 2.23, divided by N1, which is 1.01. For this one, don't forget to convert to liters. No, you don't really have to because it's a change. Just, you're going to result in milliliters by the time you're done. So the answers are in milliliters here. So in that case, also you got to remember to convert the degree C to delta K to do these. Suppose I do this. $26.6 plus 273.15 and we're going to keep out here the 5 rounds of 7. So we have that. Is that T1? T2 is 88.2. So 361.4 T2. We have V1. So in this case, we want volume and temperature on the left and everything else on the right. So we're going to end up with V over T equals NR over P. And then V1, T1, V2, T2. And we're solving for V2. So multiply both sides by T2 and you get T2 V1 over T1 equals V2. T2 is 361.4 times V1, which is 44.5, divided by T1, which is 299.8, 53.6 milliliters. It is 53.6, right?
Yes.
I bet when I did this before, I didn't keep this after the decimal. I didn't put it in here, it's not gonna be in there. Anything else? Alright. If you have questions, you can hit me up. I give a test tomorrow morning, I'll be in my office during my office hours tomorrow. If you're still confused, if you want to come ask me once. Or you can try asking by email. Especially if you're working one of my problems and it's not coming out right. I will give you equations and conversions. It's mostly just about solving problems. No other questions?
Will we need to know, like, oil law, for restriction test?
You need to know what?
Do we need to know, like, what oil law are, you know, like the agency test?
Oh, I'm not going to ask you that. I don't think they do that in ACS. They might have to use it. We just use pressure and temperature that's biggest swells on pressure and temperature. So we just use it, but I didn't name it swells. I don't think those names are important. And I don't think the ACS does either. They might mention that this is swells. They'll just do that.
As for those structures, are you gonna give us like the structures of A, B, C, D, and C, so
Yeah.
it's the right one? And then, if you do those structures,
So,
those structures,
so you do need to be able to build it, but I'm not going to have you draw them for me.
okay.
You just have to be able to draw them and answer the questions. All right, CH4. Okay, how many total valence electrons are here?
See, that's the part that, let's, I don't know, how do you know valence electrons? Is it the one where you like count,
Yeah, count to the left
you count to the left, so,
and include the atom you're looking at. So look at carbon. Put your finger on it and say 1 and then start counting to the left.
okay, 1, 2, 3, 4. Okay, and then H,
Because 1.
okay, just 1 to 5. Total.
4
Oh, wait, because there's
plus 4
4,
more.
4,
There's 4 for carbon and 1 for each hydrogen.
so 8.
So 8 total. And then you use this first atom to make a backbone and make everything else come out from there. So you start like that.
Mm-hmm.
And then you go, okay, there's 2 electrons in each line that I've used here. 2, 4, 6, 8. I'm down to 0, so I'm done. This is
That one's
easy.
right.
You could also think, some of these you can kind of think like Tinker Toys. If I said make the Lewis structure of carbon, you'd make that.
Uh-huh.
And then hydrogen, it's just 1. So you can almost just go, okay, there's the pair in that bond, there's the pair in that bond. And I've got nothing left. So some of them are simple enough that you can think of like Tinker Toys. But let's do one of these. Let's do CO2. Oh, let's do H2O. How many total valence electrons?
6, 2,
6 oxygen.
2, and 2, so 8.
Yeah, it's 8 again. When hydrogen's on the front, it's not going to be the central atom, so it's going to be oxygen here. All right. 6, 7, 8. All right.
Are you still recording?
I think so.
I hope so.
Yeah.
Awesome. Thank you.
So there's my backbone. I've used 2 4 electrons. So I have 4 left. The first thing you do is you start filling the octets on the outside. You want there to be 8 electrons around everything on the outside.
Wait, where's the 4 coming from? The
2,
minus one?
4.
Oh, okay, they're double.
So it's a total of 8, but we've already used 4,
Okay.
just to make this little backbone structure.
Okay.
But hydrogen is one of the exceptions where you don't get an octet around it.
Mm-hmm.
It never gets more than what it's got here. So once you're done with the outside atoms, you add everything left to the inside as pairs.
Okay.
So I'm going to add a pair there and a pair there. That gives oxygen its octet. It needs to have 8 total around it. There's 2 there, 2 there, and I just added 2 more there and 2 more there. And we're done.
How do you, like, with those structures and, like, the double bonding?
The next one will have a double bond.
Like, what determines that it's double bonded?
Okay, the next one, the CO2 is going to have a double bond. I mean,
Like on there?
I followed rules to get here,
Mhm.
and then everything was kosher, so I was able to stop.
Okay. So the,
CO2 won't be like that. We'll have to use another step.
but the lines that match the O to the H, it's why is it 2 and not 1 if it's not a double?
Well,
Oh, because they're connected on each side? Is that?
yeah, they're one electron from one atom and another electron from another atom pair with each other. That's what creates the bond.
Okay, because there's a electron here and electron there, and it's like
Yeah,
coming together, that makes it 2.
yeah. Those 2 separate electrons pair with each other, and that's the glue
Right,
that makes
okay.
the bond.
Okay.
All right, how many total electrons?
6, wait, so 12, and then 5, and that's 17?
Carbon has 4.
Oh, carbon has 4.
So,
Oh.
so it's 16?
16,
16 total electrons. And now we're going to make our backbone with carbon in the middle, and oxygen's out here,
So whichever one's in the front is in the middle.
unless
of
it's
that.
hydrogen,
Okay.
and then it's going to be another one. I'm happy to tell you which one's essential, because it's a little bit nebulous sometimes. All right, so how many electrons have I used to make this little backbone? 4. So I've used 4. I've got 12 left. Your next step is to start filling the octet on the outside atoms. This oxygen already has 2 because those 2 count for the oxygen. So we need to get 8 around it. So we're going to add in pairs. 4, 6. So now that has 8 electrons around it.
Do it pairs.
And I've used 2, 4, 6. I have 6 left. 2, 4, 6. And I'm down to 0. This is where the double bonds show up. You look at them and you go, okay, now does everything have its octet? Everything that should have an octet. It's really just hydrogen and boron that won't. And higher atoms can have more than an octet. But it's hydrogen and boron. Boron's never going to have more than 3 unless it's charged. But, okay, so does everything have its octet?
Yes.
Not everything.
Oh, carbon?
Carbon doesn't have an
Okay.
octet. But we're out of electrons. I can't
Yeah.
stick any more electrons on there. So what I do is I take this pair here and make a double bond. Now does everything have its octet? I didn't ruin this one's octet
Yeah,
because these 2 can still be counted over here. So
Yeah.
this still has 8. How many does carbon have now?
2, 4, 6.
6. And it needs 8, so I'm going to grab another pair from over here. There, now does everything have an octet?
Yes.
And it does an alpha.
There was another one, it was like nitrogen where it's triple bonded.
Nitrogen triple bonded.
How does that?
All right, let's find that one.
I don't know which question it was.
I'll find it. I'm sure it was a nitrogen. It won't be
I
that.
have just put them into.
Like the hint is correct, it's showing the structure.
Yeah, so what I did is I would look at it and then I would draw the structure first.
Oh,
And
he's
then
just
look
asking,
at it to see if I got it right.
oh, and that's what it's asking.
Was it maybe N2?
I think so.
Okay. N2, your backbone, there's only one way of connecting. So for N2, there's really not a central atom here, but your backbone is just gonna be that.
I guess I was just confused as to why, because there's 5 valence electrons in nitrogen, right?
Yeah.
I was just confused, like, why you couldn't just do, wait, never mind. Oh, wait, no, no, why you couldn't just do 4, like, electrons outside, because they would all have,
Well, you can, but let's go through the process.
okay.
How many total valence electrons? And how many have we used just to make our backbone?
But do you know what I mean? Like, just putting them on the outside. Like, why would that not work? Like, for,
I didn't really cover formal charge, and that's the problem with that one.
okay.
This one, once you're done making a Lewis structure, all of those single electrons have to be paired somehow. So if you're just looking at this and you went, how am I going to get all those to pair? I didn't explain Lewis structures all that well to y'all, but definitely you could do this, right?
Yeah. Well, that's what I was wondering. I just didn't know,
And
like,
then these you can do that,
yeah.
and then these you can do that. I went over formal charge one day, but
Well, 'cause I
I
really
didn't make
asked-
any questions on it.
I know that's the right answer. I just didn't know,
But,
like,
okay,
why
well,
you
let's-
didn't do the 4 around.
So that one gets its octet. That's 6 electrons, right? 2, 4, 6. I took 2 away already. And then 2, 4, 6, I've given that one its octet. I've got 2 left. And I'll put them over here. So now I'm out of electrons. Now I'll look at, does everything have its octet? So, but I don't have any more electrons.
So that's why we're in this.
So that's what we're going to do there. Does that fix it? No, not quite. So let's steal another pair there. Now everybody has an octet. Does that make sense? But I don't think you're going to need the concept of formal charge for these. Might give you.
How many questions are on the test?
I don't know, but assume 1 or 2 of each one of these, unless it's a long calculation, and then I won't do a lot of it. I haven't written it yet, so I don't know.
And you're putting the makeup points, quizzes.
I'll put them online like I do the other practice quizzes, and then you can do them whenever you get to them.
Okay.
You can do them from home, they'll be easier because you can look online or do it. I can't police that, so it's just, I'm running out of time.
Because I have so much stuff.
Yeah, I'm running out of time, and we've run out of class periods to do it in, so.
And then the folder, that's.
Okay, polarity, you got your,
That one's easy because you just look at the, like how you said in the beginning of class, you just look at the number at the bottom right and then you just, whatever that number, I have it written down so I can look at that. So that one's not.
I suppose I'll give you this on the test.
Okay.
Wait, so what all are you giving us on the test? Like that?
I mean, I'll give you the periodic table, it's got the electron negativities, I'll give you PV equals nRT, I'll give you, I give you all this stuff so you're not memorizing it. But I guess I'm not giving you all of the, I'm not giving you the shapes,
Yeah.
like you all look at those. But everything else numerical, I'll give you.
Wait. Do you understand electron configurations? Because you can. So,
1, 1, 3, 1, 3, 5.
yeah.
That's the way I
They're not bad. I was in class that day and I did not understand the video out.
Oh, you watched the video?
Yeah.
I was behind on videos, I didn't realize that.
Yeah, can you post the one that from today? Like today?
Yeah. I'll
Okay.
post that.
Okay.
The video's still going.
Yeah. Hey guys. Okay, the electron configurations then you can just help me with.
Yeah, they're not bad.
Okay. And then the rest of it I understand. Okay. I'm feeling a lot better.
All right, good.
Yes, and I feel better that we can do the spreadsheet too.
Are you doing makeup points for testers too?
I don't know yet.
Yeah.
I'm gonna see how grades are.
Okay.
And then if I
I
do,
feel like this testing is not really
yeah.
not that the other ones weren't, but it's a lot less like that.
Well, I really have not covered everything I should have in the 12-11 class.
That's fine.
No, I know y'all don't care.
I am like worried.
I still learned something new